what are the biggest technical challenges associated with a project like this? Like I know that there's a lot of partners in and there's a lot of parts to the process. Can you give me some sort of idea on what are the technical challenges and how those parts are fitting together and how you foresee um, everything working? Because I think the main thing that I want to sort of get to is how to make this a larger process. Like in the end of the discussion, I'd really love to sort of bring that back to how then this fits into the recycling plants, processes, and so on. So can you speak a little bit on that?
Uh, sure. So if we talk about technical challenges, definitely there are different layers of technical challenges for sure, including how we really design the system, how the system can operate. But all these can fall into a main topic, which is the cost to operate or the cost to manufacture this type of system. So we are trying our best to control the overall cost, not only into manufacturing it, but also to operate it, because I think this is very critical even to recycling facilities, to other battery recycling companies who are really using, who will use this system in the future. So then it boils down to the chemicals we're using, also how we design the shredding system, how we design the extraction system, how we combine them together. So there are different layers of challenges behind. And in terms of the meaning of design this unit, we actually are proposing even more than what we are doing with projects, because we know currently consumer electronic batteries are still small, so we can still handle that batteries. Let's say we just store the batteries inside our uh, cabinet or storage room. That's not a problem. But since we know that we are moving forward to electrification world, meaning we're seeing more and more EVs on the road. Then when we talk about the batteries from electrical vehicles, that's the really big headache. Nobody
Mm.
would be able to store those big battery pack inside the backyard. That's definitely not a choice. Then how we handle those batteries during transportation, then we think our system, if we can successfully demonstrate that in consumer electronic waste stream, we also have a great potential to demonstrate this project in handling EV batteries. That's the way how we think about this project. So it's a good starting point, and we will tap into a bigger and bigger batteries, and of course eventually push it to more commercialization. That's what we're doing.
So, just to follow on to what Weikang said, uh, another maybe underappreciated facet of the battery recycling economics is that there are substantial costs to compliance with DOT regulations for shipping waste lithium ion batteries. And the transportation costs for those items sometimes can equal or exceed the scrap value of the batteries themselves.
Mm.
It's particularly acute with LFP batteries, which essentially have no scrap value right now in the United States. So by performing this neutralization step and reducing the battery to shreds at the point of collection, we are greatly improving the economics of transporting these batteries to some centralized location where they can be recycled. And that should not be underestimated either, because one of the reasons for the low recycling rate for lithium ion batteries is that it is simply not economical to aggregate all these tiny little batteries into one place, transport them at great expense. By the time you've done that, there's no profit left over for the actual recycler. So um, it's sort of a truism in many ways that if a process is not economically viable, it will never scale. But we do need to solve the problem of millions of tons of waste batteries somehow. So by improving the economics of this process, I think we're going to be able to fundamentally impact the rate of recycling for batteries.
And so I just wanted to touch on that a little bit. maybe Mike, you could address this from a process point of view. How would it work, and how would it become economical?
I'll expand on what James said, and currently, and I've had experience with this personally, transporting live batteries, in other words, intact whole batteries that still have electrolyte and are in various states of charge, is a very, very costly thing. Even batteries with high recovery value, lots of nickel, lots of cobalt, to transport these, you need a special carrier. You can't, in terms of density, they're on a flatbed truck effectively, which is not a very efficient way to transport anything. And the way you have an efficient recycling program, recycling anything for that matter, is to have scale. Okay, so these are going to be large scale recycling facilities, and they're going to be bringing in materials from various distances, quite far distances, in fact, but only if you can reduce this to an inert pile of dirt, essentially. Then your trucking becomes very efficient. Then you don't need special carriers. Then you have no fire risk. You don't need placarded carriers, and there's no flammable liquids. So that it all makes it possible to create a recycling system across the continent, really, and around the world that looks actually quite familiar to some of the recycling systems we have now for other types of commodities, uh, whether it be plastic, paper, cardboard. You've got these things called MRS, material recycling facility, or material recovery facility, depending who you ask. Um, these are where the fires are happening today. So you'd have something like that for the lithium ion batteries, probably closer to urban centers where most of the batteries will be coming from. But before you send anything there, you have to inertize all these batteries. And that's where our technologies come together to create that inert material. It becomes a tradable commodity now. Now it's inert, and I can ship it. I can pack it up into a container ship it somewhere to the highest bidder, or I can send it to the MRF or the recycling facility in my state, province, region, whatever. So, it's a familiar recycling paradigm that we're trying to create. It's not you know rocket science. The trick and the value we're creating with this project that we're working on is that you're allowing that transportation ease to happen that never existed before. And you're at the same time, because you're making recycling easier and more cost effective, you're removing, hopefully, batteries from falling into other streams and getting discarded improperly. I mean, there is no bin for recycled batteries or any kind of batteries, and it's a very um, difficult thing to do right now. Recycle even EV batteries. You're picking up the phone, calling people, trying to find where to send this thing. But it is becoming easier, and with our technology, it becomes easier still, and safer and more cost effective.